Hello, I'm Daniel and welcome. Today we will be building a simple vehicle management system using object oriented programming concepts. We will learn how to use interfaces and abstract classes and concrete classes to represent different types of vehicles such as cars and motorcycles. Uh, so I'm going to demonstrate how we can model the common behaviors across different vehicle types, like starting and stopping the engine, and accelerating and braking, while allowing each vehicle to have its unique behavior. I will start by defining an interface called vehicle, which we will declare the common behaviors that all vehicle must implement. Then we will create an abstract class called base vehicle, which will provide some of the common behavior and give the specific behaviors to define by the actual vehicle types. And finally, we will create two concrete classes, car and motorcycle, which we will which will represent real world vehicles and we will demonstrate how they behave. So this interface will declare four methods: the start engine and the stop engine, accelerate, and brake. So this every type of the vehicle we create must implement these methods. In this interface, we define the core behaviors that every vehicle must have. Any class that implements the vehicle interface will need to provide concrete implementation for these methods. This ensures that all the vehicles have consistent behavior. Next, we will create an abstract class called base vehicle. Okay, this base vehicle. Uh, which will partially implement the vehicle interface. So put abstract here and implement vehicle. This handle common logic of starting and stopping the engine, but it will leave the methods accelerate and brake for the specific vehicle to implement. So we have our variable here protected. So this is Boolean engine running. Then we'll have our constructor here. It's a vehicle. Then choose engine running, protocol. Then we will have two methods. Okay. So this start engine and the stop engine. So in this side the start engine we use if clause here. Engine started. Then else. And also in the method of stop engine, same, we split else here. Like 4. Else, now we will have our abstract method here. So, okay. And also the right. So we have now our base vehicle. We added a variable engine running to track whether the engine is on or off. This variable is protected, so it can be accessed by subclasses. Then the methods of the start engine and the stop engine is handle the logic of turning the engine on and off, and it will contain a message based on the current state of the engine. And we declared two also the accelerate and the brake as abstract methods. This means the concrete vehicle classes such as car and motorcycle must provide their own implementation of these methods. Yeah, I think I forgot to put a override to this abstract method here. And also put here. Yeah. Now let's create our car class. This car extends to base vehicle. Wait, it's friend. So we'll just type here or just use this one to create right away the two methods, which is the accelerate and the brake. To set okay. So now we have two methods, the accelerate and brake. So we need to provide the specific implementations of this one in the car. So we say also is here. Then our brake, we just put here when car is brake. So in the car class, so we implement the accelerate method which checks the engine is running before accelerating. If the engine is off, then can accelerate. And we have also the brake method. So simply print the car is ready. Next, we will create our motorcycle class. This one extends also the base vehicle. Just put this to override those also the methods of accelerate and brake to provide our own implementation. For these methods, use vectors also here. What same as the contract. Then also our method break here. So in the motorcycle class, we implement accelerate method which behaves similarly to the car, checking if the engine is running before accelerating. Also with the brake method, it means the motorcycle is braking. Finally, we need to have a main class to uh, demonstrate how the uh, vehicle system works. Our vehicle system works. We will create an instance of car and motorcycle. So we'll show how they start their engine and accelerate, brake, and stop their engine. So right click first. So our vehicle, my car, then system car, go to the vehicle here. Call this one. Yep. Call the start engine. So the delivery, and get our vehicle motorcycle here. Motorcycle. Then the it's the same method. So in the main class, we just create two vehicle instances, a car and a motorcycle. So for each vehicle, we call the methods like the start engine, the accelerate, the brake, and the stop engine. So this show how the vehicle behave using the common interface, but their own specific implementation of acceleration and braking. Now, let's run the code and see the output when we test the car and the motorcycle. Let's see how the system. We'll see how the system behaves. So as you can see in the output, let's move here. You can see it. So the system works as expected. Both car and motorcycle start their engines, accelerate, brake, and stop their engines. This is state is properly handled, and each vehicle behaves according to its specific implementation of accelerate and brake. So we've seen this how to use interfaces, abstract classes, and concrete classes to build a simple vehicle management system. This approach allows us to enforce common behaviors while letting each vehicle type define its own specific actions. Thank you for the following along with this demonstration that about this abstract and interfaces. And I hope you found it helpful. And bye bye.